In this example, we're taking a little region, this pink area of the plane, and we're revolving it around the line y equals 1 to trace out a solid of revolution. So this lower curve here is 2e to the negative x. So f of x equals 2e to the negative x. It's bounded above by the line y equals 1, and then it's bounded on the right by the line x equals 3, and then we spin it around the line y equals 1 to get our solid. So on this problem, we're asked to do it using disks. So you're going to use disks that have the same symmetry axis as the solid that you're looking at. And we're going to slice into these infinitesimal little slices of volume, and then we're going to stack up infinitely many of them to get the total volume. In this case, we're just asked to set up the integral, which is somewhat of a relief because it would take a long time to grind through the actual integral that pops out of this. All right, so the width of each of those disks is just a little dx. And then I need to find an expression for the radius of one of these disks. So that dimension right there. And that has a highest y value of 1, and then the lowest one is 2e to the negative x. So 1 minus 2e to the negative x is the radius of that disk. So then I can write down a differential contribution to the total volume. dV is the volume of that little flat disk. So I have the area of the circle that's on each side of it. That's pi times the radius squared. And then the thickness, dx. And so it looks like we're ready to perform the integral, but there's one more thing that has to be done. In order to actually get the limits of integration, we have to figure out what this x value is right here. And that's the point where this curve 2e to the negative, so I'll just call it x1 so I can refer to it over here. That's the point where 2e to the negative x is equal to 1. So then I can get into solving for x. So I divide by 2. Then I'll take the natural log of both sides to get negative x by itself on the left. 1/2 is 2 to the negative 1, and I can pull the negative 1 out in front. So just a little bit of log properties tricks there, and then I get x is equal to the natural log of 2, and we'll just leave that in an exact form because we're not doing the integral anyway. All right, so back to the main mission here. I'm going to use an integral to add up all the volume contributions. So the integrand is going to be pi times the quantity 1 minus 2e to the negative x all squared. And then the limits of integration, I'm going to go all the way from natural log of 2 as my minimum value of x up to 3 as my maximum value. And there you have it. So it turns out this integral can be done symbolically. It's just really hairy, so we're not going to do it here.